This is lesson 1.4, experimental design. Our goal is, again, to be able to explain the importance of control, randomization, and replication within an experiment. So here's a term that you will see when talking about designed experiments: placebo. One of the most common experimental situations involves a specified treatment and placebo, which is an inert or innocuous medical substance. Technically, both the specified treatment and placebo are treatments. The group receiving the specified treatment is called the treatment group. The group receiving the placebo is called the control group. In the folic acid study, the women who took folic acid constituted the study group, and the women who took only trace elements constituted the control group. So this could be the study group or the treatment group. And now we have a couple of additional terms we need to be familiar with. We have the response variable, factors, levels, and treatments. These are all elements of experimental design. So the response variable, the characteristic of the experimental outcome that is to be measured or observed. So the thing that we are measuring or observing, it is the response or the outcome. Factor, a variable whose effect on the response variable is of interest in the experiment. So this is the affecting variable, which ties in with the explanatory variable. Levels, the possible values of a factor. We'll take a closer look in the example below. Treatment, each experimental condition. For one factor experiments, the treatments are the levels of the single factor. For multi-factor experiments, as we'll see below, each treatment is a combination of levels of the factors. So let's clarify on explanatory variable versus response variable. These two are often confused. Example, a medical research group wants to know if chemo or anti-estrogen treatment is a better procedure for breast cancer patients. The question is, which procedure prolongs life more? So when we have experiments, they often begin with a critical question. So this is the critical question here. And so survival time is the response variable. Right? We can see that it is the outcome. It is what we are observing or measuring. The type of therapy given is the explanatory variable. And you can see how that relates to factor. So these two are pretty much have a lot in common, almost synonymous. Explanatory variable, it may or may not affect the response variable. In this example, we have only one explanatory variable, the type of treatment. In real life, you would have several explanatory variables, including age, health, weight, and other lifestyle factors. weight gain of the golden torch cacti. So here we're going to look at one last example of a designed experiment. The golden torch cactus, a cactus native to Argentina, has excellent landscape potential. W. Feldman and F. Crosswhite, two researchers at the Boyce Thompson Southwestern Arboretum, investigated the optimal method for producing these cacti. The researchers examined, among other things, the effects of a hydrophilic polymer and irrigation regimen on weight gain. Hydrophilic polymers are used as soil additives to keep moisture in the root zone. For this study, the researchers chose broadleaf P4 polyacrylamide, abbreviated P4. The hydrophilic polymer was either used or not used. 5 irrigation regimens were employed: none, light, medium, heavy, and very heavy. And we will identify from the situation the experimental units, the response variable, the factors or explanatory variables, and the treatments. So when we look back through, we could notice that the cacti are the experimental units, the response variable, so the response that we're looking for, their aim, optimal method for producing the cacti. So they want larger cacti. So the response variable would be the weight gain. Factors or explanatory variables. So we have the polymer is a factor, and the irrigation method. Irrigation method, or regimen. And then finally, the treatments are the combination of the polymer and irrigation. So you can see the table right here displays the 10 treatments for the experiment. So each one of these squares indicates a unique treatment. The table displays the 10 treatments for the experiment. So this concludes our notes. We have several new terms to consider. You probably heard the term placebo before. We've given now a technical definition for that and some examples. We have these terms: response variable, factor, which again, explanatory variable. Those go hand in hand. They're practically synonymous. We have levels, and we have treatment. So we also discussed on the other side of these notes, we have parts of a designed experiment including control, randomization, and replication being key elements to a designed experiment. We also talked about confounding variables. So those are those non-accounted for influencing factors on an experiment. This concludes the notes on experimental design.